Hi everybody, welcome back to Geometry. This is section 4.3, Triangle Congruence by ASA and AAS. You know by now that the A stands for angle and the S stands for side. So this is angle, side, angle, and angle, angle, side. Our objective is to prove two triangles are congruent using ASA postulate and the angle, angle, side theorem. So this picture here shows angle, side, angle. Pair of angles, a pair of sides, and a pair of angles. And it's the included side. It's between the two angles. And then this picture here depicts angle, angle, side. Oh, angle, angle, side. And remember we said yesterday you can't skip more than one thing. So you wouldn't go in this direction, angle, side, angle. You would actually go in this other direction and say angle, angle, side. You can skip a side or you could skip an angle, but you can't skip over both a side and an angle when you're identifying what kind of congruence you're going to have. So it's essential to your understanding that you can prove two triangles are congruent without having to show all corresponding parts are congruent. When you prove two triangles are congruent, that means all of their corresponding parts are congruent, but you don't have to prove all their parts in order to know they're both congruent triangles. So in this lesson, we will prove triangles are congruent by using one pair of corresponding congruent sides and two pairs of corresponding congruent angles. So both of the ways to prove triangles congruent today, we're going to discuss have two angles and one side. The section 4.2, we did side, 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 and we did side, angle, side. So three corresponding congruent sides, and then two corresponding congruent sides with the included angle. So today, we're going to have two angles and one side. Two angles and one side. So remember yesterday, we talked about how you cannot have one angle and two sides unless the angle is included angle, because then you would have ASS and you can't have that geometry. So today we have ASA and AAS. So using your note templates here, you can pause the notes, the video if you need to. You would write down this postulate. Remember, postulate is a rule we accept without proof. And this is our third postulate on proving triangles are congruent. This one is angle, side, angle. If two angles and the included side, so the side has to be between the two angles, and we talked about this in 4.2 notes, what it meant to be an included side. The side is named by the angles that includes it. So if two angles and the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent using angle, side, angle. So here in this picture, we have angle A is congruent to angle D. Then we have side AC is congruent to side DF. And then we have angle C is congruent to angle F. So we have angle, side, angle. Angle, side, angle. So therefore you could prove the two triangles are congruent using angle, side, angle. And remember, you have to go in an order. You can't skip over more than one thing. So I wouldn't say I have angle, angle, side. I wouldn't go this way, angle, angle, side, because I'm skipping over a side and I'm skipping over an angle. I would have to skip over a side, an angle, and a side to get to the next thing. You can only skip over one thing when you're reading these. So pause the video if you need to fill in your note template on the postulate angle, side, angle. So example 1, using angle, side, angle. Which two triangles are congruent using angle, side, angle? Explain. Well, take a look at this first example. We have this triangle, UVS, and we have an angle, a side, and an angle that's marked congruent to triangle EON with an angle, a side, and an angle. But it's also marked that UVS and EON have congruences that correspond to this third triangle, TWA. Well, what's the problem with TWA? TWA has an angle that's congruent, so angle, and then a second angle that's congruent, so angle. The problem here is that this triangle, UVS, has the included side, where with this triangle, TWA, this side is not included. It's not the side that's between the two angles. So this one doesn't belong. These two match. U is congruent to E, so that's an angle. This side, EO, is congruent to this side, UV. And then this angle, V, is congruent to angle O. So you can say that you know that triangle UVS is congruent to triangle, I would have to say E, because it matches to U, O, because it matches to V, and therefore N. So those two triangles are congruent using angle side angle, because I have two pairs of corresponding angles and the included side. Again, if you take a look at this third triangle, this side is not included, so it doesn't match the other two. So I have angle, side, angle. It has to be a pair, a match. So using angle side angle, these two triangles are congruent. You try number 2. Which two triangles are congruent using angle side angle? They have to match. Take a minute, see if you can figure it out. So if you guessed the first one and the last one, triangle GHO and triangle CAT, you were right. They have a pair of corresponding congruent angles. Then they have the included side, GH is congruent to CA. And then they have angle H is congruent to angle A. So, by angle side angle, these two triangles are congruent. The middle one doesn't match because it's got angle, angle, side. So it does not match the corresponding parts. It does not correspond to the congruences in the other two triangles. So it doesn't match. It's not congruent, or we can't prove it's congruent. Now we're going to write a proof using angle side angle. Before we write the proof, let's develop a plan for our proof. We're given that angle A is congruent to angle D. Angle A is congruent to angle D. We're also given that segment AE is congruent to segment DE. And then what other pair of angles do you know here are congruent? Yeah, you can identify this pair of vertical angles. Angle AEB is congruent to angle DEC because of the vertical angle theorem. And therefore, you can now prove these two triangles are congruent because you have angle, side, angle. So let's write the proof. Step 1, let's write our givens. Step 2, let's put in our pair of vertical angles. And remember, you have to name them using the 3 letters because there's more than one angle E in this picture. Step 3, prove the two triangles are congruent because we have angle, side, angle. So let's write our reasons in order and our statements. So the first statement, angle A is congruent to angle D. That was given to us. So we have a pair of angles that are congruent. Then, side segment AE is congruent to segment DE. That's a side. That was given to us. Then we identified this pair of vertical angles, and using the vertical angle theorem, we know that they are congruent. Angle AEB is congruent to angle DEC. So this is another pair of angles. So our last step we could prove these two triangles are congruent. Triangle BAE is congruent to triangle CDE using angle, side, angle postulate. The next thing you want to take notes on is theorem 4.2. Now remember, a theorem is different than a postulate. A theorem is a rule we can easily prove. This theorem we can easily prove because we know the third angle theorem. So angle, angle, side. If two angles in a non-included side of one triangle are congruent to two angles in the corresponding, that's important, has to be the same one, non-included side of another triangle, then the triangles are congruent. So draw this picture. If angle A is congruent to angle D, so we have a pair of angles. Now we wouldn't go this way, angle, side, skip an angle, skip a side to the next angle, because you're skipping two things. You can't skip two things, you can only skip over one. So that's why we know we have to go in this direction. Angle B is congruent to angle E because we've only skipped a side to get there. You can only skip one, a side or an angle, right? So we have this. Angle, we actually want to go this way. Angle, angle, side. Angle, angle, side. When we read this, we don't want to skip over more than one thing. That's how you know how to read these. So angle A is congruent to angle D, angle B is congruent to angle E, and segment AC is congruent to segment DF. If I were writing a proof of this, I would actually put angle B and E first, because that's the way that I want to read this. I want to go in that direction, because I'm going to go angle, angle, side to prove that these two triangles are congruent. So using the angle-angle side theorem, I can prove triangle ABC is congruent to triangle DEF. Now we're going to go on to prove this theorem. A theorem is something you can easily prove, so let's use what we already know to prove that this is going to work every single time. Now remember, when you're proving a theorem, you can't use it yet. You have to prove it before you can use it. So here's the thing. We're given that angle A is congruent to angle D. We're also given that angle B is congruent to angle E, and we're given that segment AC is congruent to segment DF. Well, if you know that two angles of one triangle are congruent to two angles of another triangle, could we prove that angle C is congruent to angle F? That's the third angle theorem. And if I can do that, well, now I've got angle side angle. And because I can prove these two triangles are congruent using angle side angle, and I could do this every time, then I could prove angle angle side. Why take the next step to prove angle side angle if I have two angles and I know the third is congruent every time using that third angle theorem? So let's write our proof. So let's begin with this given. Angle A is congruent to angle D, angle B is congruent to angle E. We said because we know two angles of one triangle are congruent to two angles of another, then we know that angle C is congruent to angle F using the third angle theorem. So then we are also given that segment AC is congruent to segment DF. So now we can prove that those two triangles are congruent using angle, side, angle postulate. So a theorem is something you can easily prove because every single time I am given two angles and a non-included side, I could prove the third angle using the third angle theorem. We don't need to do it every single time. So because we can prove it this once, that I have angle, side, angle, I could prove it every time. So this one is called angle, angle, side. If you can say angle, angle, side, then you could go on to say angle, side, angle. And why take that extra step each time? So that's why we have the angle, angle, side theorem. So now it's one that you can use. Now that we have this theorem, you can use it every time. Let's write a proof using angle, angle, side. In this proof, you're given that angle G is congruent to angle B, and you're also given that CB is parallel to GA. Well, because you know that these are parallel lines cut by a transversal, then you know that their alternate interior angles are congruent. And also, these two triangles share a side. And because they share a side, that side is equal to itself. So both of these triangles include this segment, CA or AC. And therefore, using reflexive property, it's congruent to itself. So we can prove these two triangles are congruent because we have angle, angle, side. Let's write our proof. So the first thing we do is we'll write down our given information. We're given that angle G is congruent to angle B, and we're also given that segment CB is parallel to segment GA. We said because we knew these were parallel lines cut by this transversal CA, we could then go on to say that we know angle BCA is congruent to angle GAC because those are alternate interior angles. And then lastly, because both of these triangles contain this side, we can prove that it's congruent to itself by reflexive property. So CA is congruent to AC using the reflexive property of congruence. And now we can prove these two triangles are congruent. Triangle GCA is congruent to triangle BAC because we have angle, angle, side. So using the angle, angle, side congruence theorem, we can prove these two triangles are congruent. So that's it for our notes. Now you have 4 ways to prove triangles are congruent without having to prove all of their corresponding parts are congruent. We have side, 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 angle, side, angle, side, angle, and angle, angle, side. Remember, you can't have angle, side, side. When you write that out, it spells a swear, and you can't swear in geometry. It's the easy way to remember it. So tomorrow in class, we're going to work on identifying congruent triangles using side, 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 angle, side, angle, side, angle, and angle, angle, side.